Alright, in this video we're going to be going over investigation 5.2.1. So here's our quick warm-up. What number, if I square it, would equal 25? So it turns out for every square problem there are two sets of answers. I know that 5 times 5 equals 25, 5 squared is 25. But I also know the negative version, negative 5 times negative 5 is also going to be 25. So again, any number times itself will be positive, and a negative number times a negative number will also be positive. Here, notice that 2 isn't a perfect square. So if I want to figure out what number times itself is 2, it's probably going to be like a decimal or something. So to keep our examples exact, I can type in the letters S, Q, R, and when I type in T, I make a square root. So one answer is square root 2. The other one is SQRT. It will be negative square root 2. So notice that 1.4 times 1.4, that's going to equal 2. And if I open up my calculator, 1.414 times itself is going to be pretty close to 2. And notice that the negative version of these, a negative times a negative, is also going to be 2. So again, either the positive version times itself or the negative version times itself will turn to 2. Alright, let's do this last one. I know that square root 10, SQRT 10, or negative square root 10, negative SQRT. So either the negative version or the positive version. I know that 3 times 3 is 9, so 3.1 times 3.1 is close to 10. And negative 3.1 times negative 3.1 is also going to be close to 10. So for every square problem, we split it to a positive answer and a negative answer. So how can we solve quadratic equation involving perfect squares? That's the focus question for this investigation. So here, we're taking a look at these backyard problems. So for each of these situations, we're going to draw a diagram. And based on the diagram and based off the situation, we're going to try to write an equation and solve it. So here's our first backyard problem. Ernie is going to install a square hot tub in his backyard. He plans to add a 3-foot wide deck on 2 sides of his adjacent hot tub. If Ernie's backyard is also a square with 169 square feet, what's the largest hot tub he can order? So let's go and see if we can write an equation. I know that no matter what size hot tub he makes, it needs to have an area of 169. Right? Again, we don't know the size of the hot tub, so let's call the size of the hot tub X. And I know that no matter what size of hot tub they make, either a 3x3 or a 4x4, I know that there's going to be a 3-foot deck on each side. So it'll be X plus 3. So to find the whole area of this hot tub, it's going to be base times height. So I could do X plus 3 times itself. But another way of writing X plus 3 times itself is going to be X plus 3 squared. So now that I have my equation set up, I can now start solving for X. Let's see, to solve for X, to cancel out squaring a number, I can square root both sides. So square root that number, square root 169. And notice that square root and square, those are going to cancel out, leaving me with X plus 3. And the square root of 169 is 13. So what X value solves this? If I subtract 3 on both sides, X equals 10. 10. And hopefully this makes sense in terms of this problem. If I have a hot tub that's 10 by 10, 10 by 10, notice that I'm able to add a 3-sided deck to each side, and the whole area fits inside a 169 square unit. Let's go and take a look at our next problem. So Gabby's trying to create a decorative rock garden in their backyard. The backyard is only 12 square feet tall, so not as much space as what Ernie had. And this time, there's going to be a 1-foot frame around the garden. So let's go and see if we can write an equation. I know that the total area of the garden and the frame has to equal 12. Again, I can do a 1.4 by 1.4. And notice that the area is not quite 12 yet. So again, I don't know what the area of the garden should be, so let's call that X. But I know I'm adding a 1-inch border on all the sides, so I'll do X plus 1. And it's going to make a square. So from here, if I want to solve the equation, I can square root both sides. I can square root the left part and square root the 12. So square and square roots are going to cancel out, leaving me with X plus 1. And square root of 12 is not a nice number, so I'm going to leave it as a radical, square root 12. And finally, to solve for x, how big should my garden be? If I subtract 1 from both sides, x equals root 12 minus 1. So it looks like this has, the green part has to have an area, or the side of the garden has to have a side of 2.4. So notice that if I make it, let's see, height 2.4, close enough, and let's make the base 2.4. Okay. And notice that if I have a base and height around 2.4, notice that the total area of this section is going to be close to 12. So in section A, what do you notice? Again, I think I might have forgotten the type box here, but what do you notice anything special? We solved the quadratics by square rooting both sides. We did not use the zero product property because none of those equaled 0. So thinking about this idea, what are two answers that will make when I squared will equal 4? So ignoring this part in the middle, what squared equals 4? I know that 2 squared equals 4. So how can I make this middle part turn to 2? I know that 3 minus 1 is 2, and then 2 squared turns to 4. So one of the answers could be 3. Another possible answer, again, for each square root, there's a positive and a negative version. The negative answer could be negative 1. So notice that when I plug in negative 1, the two negatives become negative 2. And when I times that with itself, the answer is going to be 4. So again, either the positive version or the negative version, when I plug it into my equation, it will turn both parts into 4. All right, checking the next one. How can I turn this whole thing to 0? Let's see. The only way to make this 0 is if I plug in 1. So if I plug in 1, 1 minus 1 equals 0, and 0 squared is 0. Turns out for this one, 1's the only answer. There's only one way of making the whole thing 0. 0 doesn't have a positive and negative version, so we can't split it up into two answers. There's only one way to turn something to 0. Right? And for the last one, can I have something equal negative 4? Can I have a square equal negative 4? And no matter what numbers you try, you're going to see that nothing we try is going to turn the whole thing into 0, or to negative 4. So this one has no solution. That's because a square cannot become negative. Again, when we have a square, a positive times a positive equals positive, and a negative times a negative equals negative. So let's go and focus a little bit more on how many solutions each of these have. Again, this one has no solution because nothing works. That's going to turn that to negative 4. So let's go ahead and take a look at B4. So this quadratic equation, x minus 3 squared equals 12, is written as a perfect square. And the reason why it's a perfect square is because we can see what the base and height are. Notice that the base and the height are the exact same thing. So this is a perfect square. So how many solutions are there? A perfect square has 2 solutions. I can either be in square root form, square root of 12 plus 3. And this can be the square root of 12, or negative square root of 12 plus 3. So notice each time I square root it, there are 2 different answers. Either I get positive root 12 or I get negative root 12. And based on which of those answers, I can plus 3 on both sides and solve for x. So what's the decimal version of these 2 answers? So let's go ahead and copy this here and type that into my calculator. I can see that this is going to be around 6.4. Oops, 0.46. And this over here, the square root of negative 12 plus 3 is going to be negative 0.464. Or 464. Okay. So when we leave our answer as a square root, we call that leaving it in exact form. Again, if I want to find the exact answer, I could just type in this formula and figure out what the x is. And down here, these are examples of approximate form. So again, these numbers are rounded, and they may not necessarily be close to the answer. So the equations in section B either had 2 answers, 1 answer, or no answers. How can we determine whether the equations have a certain number of answers? So we're going to think about that question as we answer the next couple of questions. Okay. So how many solutions does this one have? This actually has 2 solutions. If I square root both sides, either 2x minus 3 can equal 7, or 2x minus 3 could equal negative 7. So let's see, if we add plus 3 to both sides, 2x equals 10. And if I divide both sides by 2, x is going to be 5. Over here, let's see, square root of 49 could be negative 7, because again, negative 7 times itself is going to be 49. So let's go ahead and plus 3 to both sides, and divide both sides by 2. Alright, moving to the next question. How many solutions is this one? This one's actually going to have 0 solution, because a square can't multiply to a negative number. There's nothing that times itself can ever be negative, right? So here, a square cannot be negative, because the square we're always multiplying two numbers with itself, and so whether it's positive or negative, two numbers times itself can never be negative. Here's C3. This one has two different answers. Right, the answer could be either the square root of 20 or the negative version. So here, let's go ahead and minus 4 on both sides. X equals square root 20 minus 4. And for the negative version, x equals negative square root 20. And then minus 4 on both sides. So here's the positive and the negative version. Here, how many solutions does this one have? This one actually only has one solution. There's only one way to turn this to 0. So I know that the square root of 0 is 0. Alright, if we want to solve for x, let's move 5 to the other side. Negative 10x equals negative 5. And if I divide both sides by negative 10, x is going to be 0.5. And this is going to be my only solution. There's only one way to make something turn to 0. Is by making it 0. 0 doesn't have a positive or negative version. Okay, here we're still dealing with a negative number. Again, nothing times itself can be negative, so this one has no solution. A square can't multiply to a negative. Alright, C6. Here, notice that if we subtract 5 on both sides, it's going to be equal to 0. So if I minus 5 on both sides, x minus 11 equals 0. And from here, I can square root both sides, so x minus 11 equals 0. And to solve x, I can do plus 11 on both sides, so x equals 11. Right, this is the only solution. Right, so based off our patterns, how can we tell whether the answer is going to have two solutions, one solution, or no solutions? So here, if I minus 6 on both sides, notice that a square is going to equal a negative number if I minus 6 on both sides, and a square can never equal a negative number. Here, I can square root both sides, and notice that there's only one way to turn something to 0. This has one answer. And then here, if I square root both sides, again, either square root 11 or square root of negative 11 can make this to 0, or turn it to that number. So this one has two answers. So to answer the focus question, how can we solve a quadratic equation involving perfect squares? We can square root both sides to help us solve for x. Right? A square problem will either have two solutions, one solution, or no solutions. All right, and with that, I think this is where we stopped in our lesson today. So if you still have questions, let me know.